Today we are going to discuss section 9.2, properties of matrices. Our goal today is to perform translations using matrix operations. So a matrix is an arrangement of numbers. As we can see, there's an example on the right. An element is what we call each number in a matrix. We name using row by column. So for example, this one has 2 rows and 3 columns, so we say it is a 2 by 3 matrix. When using it for coordinate points, we list the x value or the x coordinate in the first row and the y coordinate in the second row, and we list the points in order. So maybe this was a triangle ABC, where A was the point 1, 4, B was the point 3, 6, and C was the point 5, 8. Use a matrix to represent the polygon below. So we're going to draw our square bracket, and then we are going to ASDF, name the polygon, or put the vertices of the polygon, and now we're just going to write the coordinates. So A is the point -5, 7, so we'll put -5, 7. S is the coordinate 4, 6. D is 4, -2. And F is -3, -3. And we have now converted this polygon to a matrix. If you want to put the little X and Y in front to help you to start, by all means do so, but you do not need to do that. When adding or subtracting matrices, you simply add or subtract the corresponding elements. So this one, for example, and in the example here, I'm going to write out the work. You do not need to. So, corresponding elements. This is 7 plus -8. Two plus 1. -5 plus 4. And 9 plus 0. And then I simply add those elements together. And again, you can go from this matrix, the beginning, the adding 2 matrices, and go to the answer. This is what I call the work matrix, and it is not required for the adding or subtracting. Try to subtract these 2 matrices. And again, I am showing the work here for your reference. You do not need to do that. You can simply go from the problem to the answer for the adding and subtracting problems. So you have -10, 5, 4, 1, -4, 4. A translation matrix can be used to find the vertices of a polygon when given in matrix form. The matrix below represents triangle FGH, so we will label this as FGH. Find the image matrix that represents a translation of 3 units right and 4 units down. So what we will do is we are going to add, and then our matrix will go in front. Whenever we are doing a transformation, the transformation matrix goes first. And so if we're going 3 units right, we are adding 3. And if we are going 4 units down, we are subtracting 4 from the y value. Now, in order to add them, they have to be the same size. So we will make this also a 2 by 3. And now we will simply perform the operation. And when we are done, we will label this as F prime, G prime, H prime. Now, the tricky part and part you hear most about matrices is with multiplying. There's lots that goes into multiplying two matrices together. First of all, when you have matrix A and matrix B, in order to multiply them, the number of columns in A has to equal the number of rows in B. And it shows here, you know, if you have m by n and n by p, basically you have the n's here, they're equal, and our result is m by p. I will have you multiply 2 by 2 matrices by another 2 by 2, simply because that's what I'm focusing on, and with rotations and stuff coming ahead, that's what we'll be working with. So to multiply matrices, we multiply each row in A by each column in B. And I'll show you an example here. I do expect you to show the work matrix. So the first one we call A and the second one B. So we split the first one into rows and the second one into columns. Alright, now what we do is we multiply the first row in A by the first column in B. So we're going to have 3 times 4 plus negative 5 times 0. That will give us the first row, first column element. We are going to multiply the first row by the second column. So 3 times negative 1 plus negative 5 times 6. And that'll give us row 1, column 2 element. And now we will go and multiply row 2 by column 1. So we're going to have 1 times 4 plus 4 times 0. And lastly, we will multiply row 2 by column 2. So we're going to have 1 times negative 1 plus 4 times 6. And now we are going to go back and do the operation here. So 12 plus 0 gives us 12. Negative 3 minus 30 gives us negative 33. 4 plus 0 will give us 4. And negative 1 plus 24 gives us positive 23. And that is what I expect you to do. I do expect you to show the work matrix for multiplying. All right, here is another example. I'd like you to try this example on your own. All right, so again, we are going to multiply row 1 by column 1. And if you need to, this is A, this is B. So we're going to have 5 times 2 plus negative 2 times 5. We get 10 minus 10, which is 0. We're going to multiply row 1 by column 2, so we have 5 times negative 4 plus negative 2 times 1. and we get 20 minus 2. Oh, sorry, we had negative 4, so we have negative 20 minus 2, we get negative 22. You do need to be very careful of signs. It is very easy to make a mistake on these. 1 times 2 plus negative 1 times 5, so we get 2 minus 5, we get negative 3. And lastly, we have 1 times negative 4 plus negative 1 times 1. So we get 0, negative 22, negative 3, and negative 5. When doing these, make sure you double check your work. Again, you do need to show the work matrix. Double check your work to make sure you make no errors. They are very common when multiplying two matrices together.